question 22. This question has an internal choice. Both parts are tested from the same chapter, triangles. Let's get started with the first one. In the figure, we'll have a look at the figure. Okay, there's a triangle ABC given, and then what else is it? Altitudes AD and CE of triangle ABC intersect each other at point P. Okay, AD is an altitude drawn to side BC. CE is an altitude drawn to side AB in the same triangle ABC. These two intersect at point P is what is said. Okay, they want us to show that triangle ABD is similar to triangle CBE. That's the first thing. Triangle PDC is similar to triangle BEC. Let's look at one at a time. Let's start with the first one. We'll have to establish triangle ABD. Right, ABD is this triangle, right? So I'll just look at it. One of the angles in ABD is essentially D is equal to, I'm writing here, D is equal to 90 degrees. It's a right angle, right? Angle B, we'll call it as angle B itself. So the second angle is equal to B. Angle D is equal to 90. Angle B, we'll call it as B degrees. So two angles in triangle ABD are 90 degrees and B. Let's look at triangle CBE, right? This I'm not shading it because it'll confuse us. So in CBE, angle E in this triangle, angle E is equal to 90 degrees. CBE, the second angle is angle B, which is equal to B. Two angles of both these triangles are equal, which means the third angle necessarily will have to be 90 minus B and 90 minus B, which is the third angle. In one case, the third angle is essentially going to be angle A, which is this angle, and in the second case, it's going to be angle C. Both of those angles are going to be 90 minus B. So by AA or AAA, we've established that these two triangles are similar triangles. By AA or by AAA, how we can say AAA? Essentially, angle A is equal to 90 minus B. Angle C is equal to 90 minus B. So by AA or AAA, triangle ABD is similar to triangle CBE. Done. Take a look at the second part. We'll have to establish a triangle PDC. Okay, PDC is this triangle. This is triangle PDC is similar to triangle BEC. BEC, right? Let's take a look at that. We'll start with triangle PDC. Angle D is equal to 90 degrees in this first thing established. Angle C is equal to, we'll call it angle C. Angle C is equal to C. So what will be the measure of angle P? That is going to be equal to 180 minus 90 minus C, which is equal to 90 minus C. Let's come to triangle BED, right? Triangle BEC, sorry, triangle BEC. This is the triangle we are looking at. Angle E is equal to 90 degrees. BEC has the same C, right? This is the BEC, and for this we're essentially talking about C, which is essentially DCP or BCP, which is the same value. So angle C is equal to C in this case. This is your angle C for both the triangles BEC and PDC. Therefore, essentially angle P will be equal to 90 minus C. As we observe here again, by AA or by AAA, the three angles of triangle PDC are the same as triangle BEC. Therefore, these two triangles are similar triangles. We establish similarity. So 22A, we've established similarity in both instances from both parts using AA or AAA. 22B is the second question within this, which is an internal choice. Take a look at it. In the figure, DE is parallel to AC, right? DE is parallel to AC. These two are parallel lines, okay? And it says that DF is parallel to AE. DF, I'll use double arrows to denote that, is parallel to AE. Wonderful. Prove that BF by FE is equal to BE by EC. That's what we need to prove. BF by FE is equal to BE by EC. Right. We said that these two lines are what? Which two lines are parallel? DE and AC are parallel. These two lines are parallel. Right. These two lines are parallel. Look at it, AC, and then we have in triangle ABC, there is a line DE which is parallel to side AC and cuts these two sides AB and BC at D and E. By basic proportionality theorem, in triangle ABC by BPT, we can essentially say that BD by DA is equal to BE by EC. Right. We're essentially looking at these two lines as parallel lines, ABC being the triangle. So BD by DA is equal to BE by EC. This is one done. Now let's look at these two triangles, right? Essentially, we're going to look at in triangle ABE. That's a triangle we are looking at. Triangle ABE. Again, by the same basic proportionality theorem, we have AE as ABE being the triangle, DF being a line parallel to this. Therefore, by basic proportionality theorem, BD by DA, that holds good here also. BD by DA is equal to BF by FE. This is 2. Look at the left hand side of both these equations you have written. BD by DA is what we have in both these sides. Therefore, the right hand side should also be equal. BE by EC should be equal to BF by FE. Is that what we'll have to prove? Yes, BF by FE is equal to BE by EC. We've established it. How did we establish it? We wrote 2 basic proportionality theorems based on one triangle ABC, where the parallel line essentially happens to be this line DE. Another triangle is ABE, where the parallel line to the side AE is DF.
Before you leave, I want you to do 2 things. 1, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. So get it done today. And second thing, I want you to subscribe to this channel if you already haven't, and turn on notifications so that you get notified every time a new video is uploaded. And also, spread the word about this channel to your friends and classmates.